Okay, we are live. Hi guys, Vasa here from the Ethereum Labs. Welcome everybody to the Hack Night. We were talking about a little bit of the mindset we use when we program on our smart contracts and front end, of course, on Ethereum SOAS. And yeah, we will have a chat together about this. Uh, yeah, one of my favorite sentences, Kai, is always learn from experience, which doesn't mean only your experience, but even others' experience. This could be a little bit tricky if you, for example, are talking about an argument that can be extremely extremely depending from the subject of the argument itself. But you know what? Software development is math, and math is a pillar. Okay, so software development is highly deterministic. This means that the math always wins, and this could be used for future use without any kind of bias. Okay, so you can learn from someone else's experience and from your errors and from your successes too, because the approach I love the most in software development is the spiral one, which is this one I'm sharing with you right now. The spiral one. Spiral one is like the classic spiral. You divide paper in four slots, and you have the analysis one, the design one, the develop one, and the test one. So every time you have to approach on a software development problem, you have at first analyze it, okay, find all the strength points and non-strength points, design a solution to the problem you targeted, develop it, okay, and test. And then you can restart with a new knowledge, relearning from scratch, but using what you already done. And so when you terminate the development of something, you can reanalyze it to see if you can do something better, redesign a new solution, redevelop, retest, and whatever, and the software grows with you. This is the approach that we already used when we started to our journey, and this is what we daily do. Just learning from what we did, from what we are doing, and from what other people's doing, just to have an inspiration. And you can use everything because of the math, because of the software development. You can reuse, remodularize everything you see, and you can reuse in the way you like the most. And this is the approach we used when at first created the Swiss knife, for example. Swiss knife is our starting repository, which contains a lot of boilerplate code we used in every piece of Ethereum SOAS code. It is on GitHub. You can navigate on it, and it contains the most simple things, but the most important ones, because they are the pillars of everything. For example, let me just change the sharing screen. Yeah. One of the most important smart contracts, which are interfaces of smart contracts in Swiss knife, is the lazy init capable element. Every These smart contracts, okay, this is, first of all, this is an interface, so this isn't a smart contract. It's just suggest what every element like this will contain, is something that is extremely useful in code reuse approach, because it contains all the bases that every smart contract should have. For example, the lazy init. Lazy init method is a method that lets you at first create, deploy a smart contract, and then only initialize it. Usually, smart contracts have the constructor method, but there could be some typical situation where you cannot use the classic constructor in smart contracts, and you have to have an alternative. You have to think about something more. For example, in factories, this is extremely important. So the lazy init is used to initialize your smart contract after the deploy. So this is kind of two-step initialization: deploy first and initialize as a second. And for this reason, because of these two asynchronous steps, because the construction of the smart contract, the deploy of the smart contract, and the initialization one can happen in two different times. For example, I can deploy a smart contract now and initialize it after 2 days, 3 days when I want. Okay, so it is important for us to track, for example, who is the initializer of this smart contract, which is not the one who deployed it, but the one who initialized it, who called the lazy init for the first time. Of course, lazy init must be created in a way that it could be called just one time, because if you, for example, can call lazy init several times it is not just an initialization, it's a reinitialization every time. Maybe your logic, the logic of your smart contract could use it, but it could be better to call it just one time. And for example, if you this is of course the model, and we have a stretch of implementation of it. And if you look at the implementation, which is in the impl package, okay, we can see that, okay, says if the initializer has a address 0 value, you can continue with the initialization. If it's not, the init error message will be called, because of course it is already initialized. And this is useful, for example, in factories, to create your own smart contract with this logic. Let's go deep in other methods of the lazy init capable element. Another one could be, for example, the host. Okay, each smart contract could have, which is not have to, could have a host that can do something. For example, update the URI on something or whatever. Of course, a host could change himself. So there are the methods host and set host that only the original host can call to change the address of the host itself, and a method that let us just take notes of how many hosted passed through that smart contract. And this is the base of everything for us. For example, in new organization, it is extremely important. And yeah, another the last method, which is the subject is authorized for, is something we really wanted to bring into the Web3 world from the Web2 world. You know, Web2 world is about web applications. Web applications usually have different type of users that can use it. For example, you can be a manager or a simple user. If you are a simple user, for example, you can just change your password. A manager could change the simple user's password and his password himself. It's just about permissions, and the subject is authorized for is useful for us to manage all the permissions of these smart contracts. For example, this method say to us who is calling the smart contracts, what method of the smart contract is calling, and which is the payload, so the data is passing to the smart contract. And as a method like subject is authorized for for example, have an access table or a user access control methodology that lets you choose if a user can call a specific smart contract over another one, but in a total general purpose way, okay? This is, for example, is extremely useful in organizations because you have the organization smart contract, okay, and the treasury manager smart contract. Who can, for example, transfer values from the treasury manager through through a destination? Only the proposal manager can. Okay, so the treasury manager contract called subject is authorized for to see if who is calling it is the proposal manager. And of course, how a proposal manager can be triggered through a proposal. So the circle is closed. Everything is totally secured because of this kind of logic. Let's go deep, for example, in the implementation of the simple implementation of the subject is authorizing for. It's pretty simple at start, okay? Subject is authorized for is here. This is the basic implementation. First of all, because this is the simplest one, your smart contract can have a more detailed one, and for this reason there is the subject is authorized for method and the underscore subject is authorized for method. These are two different methods that can be called in different times. So people call this, but internally the smart contract is calling this, which is now empty, as you can see, but the method is virtual. Virtual method in Solidity means that this can be overridden and you can rewrite your own logic inside it. For example, in the case of the treasury manager, people is telling me that they are not able to see the screen. Maybe I can zoom it. You can see better now. I don't know if other people can see my screen, but never mind. I can send you. Yeah, people is telling me that the screen is not seeing. Okay. Got it, guys. This is the smart contract I'm talking about. You can go at line 71. Line 71 of these smart contract is the subject is authorized for method I was talking about. This method, as you can see, is empty and it can contain your own logic. For example, in the case of the treasury manager, this method will contain the logic that asks if the address which is calling it is the proposal manager. So you make the proposal calls the treasury manager to send your assets, and the assets can be moved only if the treasury manager if the proposal manager is authorized to transfer them. And this is how the logic of the lazy init capable method works, because it is the base of every kind of smart contracts. Item has it, covenants implementation have it, organization have it, and whatever. This is created through our experience uh, in Ethereum Slice. Going deep into the Swiss knife repository, we have, for example, dynamic metadata, and I'm going to share you here. Uh, Dynamic metadata package as the dynamic metadata capable element, which is a lazy init capable element. If you see the declaration at line 6, because every smart contract could add a URI, and these URIs for us, for our ecosystem, could be dynamic or static, no matter if it is an item, a factory, or whatever. Every factory or every element could implement this interface and inherit all the logic of the dynamic metadata capable elements. What are the methods? They have the URI. URI is the standard method used in a lot of smart contracts on Solidity on Ethereum that can send you back the URI. In the case of the dynamic metadata, it is calculated dynamically. But if you want the whole classic URI, you can call the play URI method. If your smart contract prevents it, you can have the set URI method that, for example, only the host can set, because a host is inherited by the ILAZine capable element method interface. Sorry. Dynamic URI works with a concept that we call the resolver. So to create a URI, okay, you can create the URI as you wish, as you want, but we don't know what are your intention and how you can create your URIs. You can do everything you want by creating a URI resolver. You can use the standard one, or you create your own URI resolver. And for example, if you are the host of this smart contract, you can set another URI resolver when you want. So this is the base interface of the dynamic metadata capable element. Let's take a closer look to the implementation. Let's see. Okay, the dynamic metadata capable element, and I'm going to share it to you. Okay, so when you create a dynamic metadata capable element, which I remember you is a lazy init capable element, it inherits the lazy init method. And you can use this method to pass all the construction elements at start of these smart contracts. In the case of the dynamic metadata element are, for example, the URI, the dynamic URI resolver, the one you wrote to draw your URIs, and if you have some data that you can pass to the caller of the lazy init method, if there are any. How the URI draw works. When you call URI, the internal URI method is called line 33, and you can see the implementation at line 46. If a dynamic URI resolver is not provided, the plain URI is passed as is, so it looks like any other smart contract having classic URIs, like classic NFTs, for example. But if you have the URI resolver, it is called to resolve your URI. So when you have to render a dynamic one, the dynamic URI resolver you yourself wrote. This is written by the user, okay? So it contains your own logic, your video game logic, your description logic, and whatever to resolve this URI. So to grab the data and pass them to the caller of the URI method. This does the magic because this is dynamic. So if you're the host of the contract, you can change it if you want. and you can render what you want inside it. So the logic of the rendering is not hard cabled by us. You are able to write your own logic using a really standard interface and approach. And let's see what we can do with it. Implementation, dynamic URI resolver. Of course, we have a little implementation of the resolver because it is pretty standard. I'm sharing with you. This resolver can do something extremely particular. Let's take a closer look to the resolve method. Of course, you can call this outside of the URI method if you want, because it is an external contract. But calling from the URI method does the magic. First of all, I don't know what you wrote inside your resolver. So for this reason, this is a little security trick we made. The resolver method, okay, is called by the resolver itself. So when you call the resolve method from the outside, the resolver calls the resolve method itself on himself. Why this? This is a particular approach. I don't think you can find it in any other place, but this is useful for this one, the try-catch method. Okay, this means that if you do some mistake in rendering your URI because of an error, the entire call the user does is not reverted. Okay, so let's make a little example. I wrote a wrong dynamic URI resolver. Okay, with a bug inside. If the user calls the URI method, okay, this call will revert. So think about something you do inside, don't know, something having something linked, for example, to a DeFi stuff, okay, which is extremely dangerous because there are assets involved, okay, and the resolve method calls error. Everything is reverted, and maybe you can hold the smart contract. You can hold your funds forever, and there's no way to grab them back. Using this method, okay, if the resolver launches an error, the call is not reverted, but the plain URI is given back again. So the call doesn't revert. The data of the plain URI are wrong, okay, but you don't lost your funds. This is extremely important for us. This is what we needed, the extremely security. Let's see how and what a plain URI contain in a dynamic one. Maybe we can read some questions from the chat. Just give me a second. Okay. Do we have some questions, guys? I arrived late. What files is inspecting the Swiss knife repository? I have to rewatch the replay. Okay, never mind. Okay, no questions in here. So yeah, we are recording this event. Okay, so these are the dynamic metadata, and now we'll go into the factory. But before to talk about the factories, I want to share with you something we wrote in the libraries of the Swiss knife, which is extremely important for us, which is the general utilities method. I am searching for the correct link. Here. Okay, general utilities, always in Swiss knife, is a general purpose library containing a lot of utility methods. The most important is the one I highlighted right here, line 55, the clone method, because it is used by the factories. What it is used for? Factories, okay, clone contracts. So you wrote your smart contract with your own logic, put it on chain, not initialize it. You remember the difference from the Let's Init talk we did before? So the smart contract is, with your own model is deployed and put on the chain. Your factory references your smart contract. The factory calls this method, the clone method. So you have the original contract. The assembly code does the magic for you. It simply grabs the model of the smart contract, so the entire code, the entire bytecode of the smart contract, and simply clones it. So from your smart contract model, it clones and create another one that the factory can initialize with your own data. So think about what the farming contract does. The farming contract factory does. We deploy the farming contract, then use the factory to clone them. And the factory initializes it for us. Exactly. With your own settings inside. So the code is what was written once, and the factory clones it through this method. Just simply grabbing the bytecode of the contract from the blockchain and reinitializing it every time. Okay? And this is how factory works. Let's take a closer look to the factories. Factory model factory. This is the code of the factory. What is a factory? Factory is a dynamic metadata capable element because the factory can contain static or dynamic query you can use to share with your users what that factory does, what that factory contains, how that factory works, what that factory does, okay? By simply having a dynamic or static router. A dynamic router, a dynamic metadata in this case can, for example, returns you in real time how many contracts have been deployed from that factory or other cool stuff. Just reading the dynamic metadata capable element directly from the chain and spit it on your front end without any other man in the middle server, Web2 server, directly from the chain. This is how we designed it. We created the standard things and then use it. Dynamic metadata capable element is also a Let's Init capable element. Why this? Because who initializes for us all the factories? The factory of factories, and everything is used in the same way. So you can create your factories. The factory of factories initializes it for you, and you can use it. This is how all the stuff works. What the factory does for you. First of all, use the deployed event. This is, I think, the most important event of all the Ethereum world, because when you have a factory, you have to think about the factory as a beacon. Okay, a beacon means that you can search just in one place to have all the deployed contracts from that factory, of course. Think about, for example, the page of the items or the farming contracts within contracts. The front end simply calls the factory of the farming contracts and see, okay, give me all your models you cloned. Just give me all the deployed method this factory launched. And that is the list, without, again, any kind of man in the middle Web2 servers needed. Everything is on chain, everything is public, everything is censorship resistant. What is the factory? Factory has a model, as we said. You create your own smart contract and use the factory to create it. So the people don't need to create by their own. If you are the host, for example, if you want, our factory doesn't, but if you want, you can do it. You can set the model of the factory. You can see who is the deployer of the method of that specific implementation of that specific element of your factory. As you remember, if you remember, I see that it can be a different stage when you deploy the smart contracts and when you initialize it. So the initializer of the smart contract is contained inside the smart contract itself. But the deployer who said to the factory deploy this is saved into the factory, and you can ask for him every time. And then, of course, there is the deploy method. The deploy method accepts the deploy data bytes argument. This is for general purpose stuff, because the deploy data, I don't know what your model does. I don't know what you can do with your own factory. I can let you just use the general purpose data, and in bytes you can save everything you want. For example, in the case of the farming contracts, in this deploy data, we save all the stuff needed to initialize the farming contract. So the factory creates it and then call the lazy init method to initialize the contract itself. Okay, let's see a little bit of implementation of this stuff. Factory. Let's take a closer look at the deploy method right here. So every time you create a new farming contract, you're not developing by your own. You're not deploying by your own. Sorry, you can the deploy method of the factory, passing all the data. What is done? The contract is cloned, calling the clone method we already set, and then call the initialize, the lazy init method on the element, passing the data. So I pass the data to the factory creates the contract and initialize it for me. And in fact, who is the deployer of this contract is who is calling the factory. So if I call the factory, the deployer of this farming contract, for example, is me, is myself. And then the launching method is the deployed event is launched, is emitted, and it is indexed inside the Ethereum blockchain. And this makes your farming contracts appear in the list of the other contracts. That's it, guys. This is how a factory works, and we can talk about it later when in the next releases. In the last event hosted by Matteo, Frank, and Jeep, they talked about the way we used to save a lot of gas while deploying farming contracts through the factories, and it is real. I'm going to show you why and how we save the tons of gas for it. Let's come back to the clone method, which is again this one. I am reposting it for you. The clone method, as we said, just clone the entire bytecode of the smart contract. So I deploy the model, I grab it, and then initialize it again, redeploy it again. This is the expensive part of the process, because cloning the contract is extremely expensive. I think, and the conclusion we arrived to is that we needed to bypass this part of code that can be extremely expensive, of course. How? Just thinking that it is not necessary to clone the entire smart contract, okay? Because what we need is just the logic. Think about the farming contracts, okay? The farming contracts is always the same. It is the storage which is different. For example, I have the farming contract for token A and token B. The code is the same, but the storage is different. In the first smart contract, the storage says that the reward token is token A. In the second one, the storage says the token is token B. What this means? Means that the code is the same, but you have to find a way to bypass the problem of cloning the entire code, and you can just create a new storage that uses the previous code. So the code is deployed just one time, the storage is replied several times, and this is the way we used to save gas when creating when deploying from the factories. I'm going to show you what we are talking about, and it is here in the creator library. I'm showing you here. Okay, what we created is something like this. You have the model of your own your smart contract you previously created. Now here it is called source, and what you clone from the factory, it is not the code of source itself, but it's just this piece of code you can see here, the general purpose proxy, the one I passed you. So every time for the new factories, they don't clone anymore the code, they just clone this one, the general purpose proxy, which is extremely tiny. So being extremely tiny means that the deployment gas is really low. And this simple code written like this does the magic for you as the same contract. So you have the farming contract, okay, that is not cloned, but it is passed through the constructor line 35 to the source, to the constructor method. The smart contract saves it through assembly, low-level code, into the storage of the contract already created. And every time you call a method of your farming contract, the method is targeted by the fallback function, which takes the source code of the original farming contract and just call in through the delegate call. Delegate call. Delegate call is an extremely powerful method in Solidity that lets you call something on your smart contract by using another code of another smart contract. This lets you have just one farming contract deployed, and all these, let's call them satellites smart contract, that exploit that contract, recycling all the logic. And this keeps the gas cheap when you can deploy a new farming contract. So you don't have to clone the entire contract, but just the logic itself is took from the original model. And this is the magic, because this delegate call is designed to call everything inside the original model. So open position, add liquidity, remove liquidity. Every time you call one of these functions, the fallback function is called, and it acts to call the correct function you are calling from the outside automatically. The delegate call exploits the trick that uses the storage of general purpose proxy. So it doesn't use the storage of the original farming contract, but the but just the general purpose proxy one. So this means that every time you clone a general purpose proxy, you're creating an empty storage that uses the old code. Using the old code doesn't mean that also the data of the model are used, because the data, so how is your position made, what is the reward token, how is the reward, is in the general purpose proxy. And this does the magic. Uh, what this is a usual trick used in Solidity. For example, even USDC uses a trick like this. But what we needed was to don't make any kind of edit of the original farming contract. So if you create a farming contract right now, even if they are created in a different way, the code is 100% the same of the one we already created before this edit. Because using this trick, the delegate call one doesn't affect the way you program your smart contract. So this is extremely powerful, because when you create again a factory, you have to deploy your own contract without the need that it is used through a factory. So it can be used in both ways if you want, through a factory or as a solo one. The factory gives you the security in plus. This is what we did using the store and sload methods like this, because other project doesn't use magic keys to save the source method. We did just because in this way the source code doesn't need any kind of edit. So you can recycle 100% of your previously written code. And using this trick, you can redeploy any kind of smart contract you think about, even the ones that you already deployed. And guys, I think that I finished my little presentation of the code of Swiss knife. These are just a bunch of non-final smart contract, because they are all abstract contracts, interfaces, and whatever. But this Swiss knife is at the base of every project we realize that we are realizing, and everything works in the same way. Using factories, using dynamic metadata, using the lazy init method, using the authorization table like I show you, and whatever. And I don't know if you don't have any other question about it. I think that we can finish here. I'm just waiting if you have any other question. Someone is writing. Let's wait. Okay, no any other question? Very thorough. Okay, if you have any other question, guys, let me know. I can answer you when you want. Okay. Nothing. I think we can close the event here. Okay. Thanks for following me, and see you next time. Bye bye.